In this section, we will talk about the derivatives of logarithms. d dx of ln x, so the derivative of natural log of x, equals to 1 over x. Now let's say instead of x we have some function f of x, then the derivative of natural log of that function f of x equals to 1 over f of x, same principle as this, except we now have to use the chain rule and multiply by f prime of x. If you prefer, you can write it like this: d dx of ln u, since we're used to using u, equals to 1 over u times u prime. You could do it either way, it's the same thing. So we want to find the derivative of the natural log of 7x minus 3. So first off, f of x, or u, or whatever you want to call this, equals to 7x minus 3. And so f prime of x, the derivative of f of x, is going to be 7. So the derivative of natural log of 7x minus 3 by this rule is 1 over f of x, which is 1 over 7x minus 3, times f prime of x, which is 7. So the derivative of the natural log of 7x minus 3 is equal to 1 times 7 is 7 over 7x minus 3. Just remember that 7 is like 7 over 1. So we multiply the numerators and then multiply the denominators. Next, we got f of x equals to 3 times the natural log of 1 plus 6x. So once again, if you want to, we say that f of x equals to this expression, which is 1 plus 6x. If you want to use u, that's fine. And f prime of x, the derivative of 1 plus 6x is going to be 6. So by the rule, the derivative of the natural log of f of x equals to 1 over f of x times f prime of x. So this is f of x is 1 plus 6x, so we have 3 times 1 over 1 plus 6x. 3 is the constant, so that's going to just stay where it's at, times 1 over f of x, which is going to be 1 over 1 plus 6x. And then we multiply that by f prime of x, which is 6. So 3, 1, and 6 are all in the numerator. This gives us 18 over 1 plus 6x. And this is equal to f prime of x. Now let's say we want to find f prime of 5. Well, f prime of x is equal to 18 over 1 plus 6x. So f prime of 5 is going to be 18 over 1 plus 6 times 5, which is 18 over 31. So the slope of the tangent line at x equals 5 is going to be 18 over 31. Okay, next example. We got f of x equals 3x cubed times natural log of x minus 2 over 7 x cubed. So when we take f prime of x, notice here that these two terms are being multiplied, which means we have the product rule. So this is a and this is b. And just a quick reminder that if you differentiate a product a times b, then this will be a prime of b plus b prime of a. So our a term is 3x cubed. So a prime is going to be 3 times 3, which is 9, x to the second power. And b is natural log of x. So we have a prime, which is 9x squared, times the natural log of x. Plus, we got b prime of a, b prime times a. So b is natural log of x. Now the derivative of natural log of x from here is equal to this 1 over x. So b prime is simply 1 over x. That's the derivative of the natural log of x. That's equal to 1 over x. And we multiply that by a which is 3x cubed. Minus the derivative of 2 over 7 times x cubed. The 3 multiplies with the 2. 2 times 3 is 6. So we get 6 over 7 x to the second power. Okay, let's simplify this. 9x squared times natural log of x, that's just going to be 9x squared natural log of x. Now this x and x cubed, we can reduce that. So this becomes a 3, this becomes a 2. So this becomes plus 3x to the second power minus 6 over 7x to the second power. Because these are both x squareds, we have to combine our like terms. So I'm going to write this as 3 over 1 and get a common denominator. So between 1 and 7, my common denominator is going to be 7, which means I multiply this by 7, multiply this by 7. So if I rewrite this, here's what I get. I get 9x squared times the natural log of x plus 21x squared over 7 minus 6x squared over 7. And then once I get a common denominator, I can combine my like terms. So this gives me 9x squared times the natural log of x. 21x squared minus 6x squared, that's going to be 15x squared divided by 7. And this will be the derivative, or f prime, of x. All right, next example. We want to differentiate f of x equals to 2 radical x times the natural log of x. All right, so first, let's say that this is a and this is b, because what do we have? We have a product of two different terms. Okay, so when you have the product rule, that's a prime b plus b prime a. Okay, so I'm going to rewrite this. So I'm going to let f of x equals to 2x to the 1/2. Any radical has to be written in as a rational exponent times natural log of x. So once again, this is my a and this is my b. Now on the side, I'm going to figure out what is a prime equal to. So I multiply the 1/2 times 2, which gives me a 1, times x to the negative 1/2. And if I simplify that, this gives me 1 over square root of x. This goes to the denominator, becomes positive 1/2, which is the square root of x. Okay, so my a prime equals to 1 over radical x. So when I take the derivative of f of x, I have a product of a times b. So I'm going to say it's a prime times b plus b prime times a. And the derivative of this, a prime, is equal to 1 over radical x. That's my a prime. Times b. b is just going to be the natural log of x. Minus b prime. So the derivative of natural log of x, that's just equal to 1 over x. Times a, which is 2x to the 1/2. Now we got to simplify this. So we get f prime of x. This is like natural log of x over 1. So if I multiply the numerators, I get natural log of x over radical x. Now here's what's happening. This is on the numerator, and this is on the denominator. So the quotient rule for exponents says that if you divide the same base, we subtract the exponents. Okay, once again, divide the same base, subtract the exponents. This is going to give me 1 times x. 1/2 minus 1 is negative 1/2. So I get minus 1 times 2. I'm sorry, 1 times 2 is 2. So it's minus 2x to the negative 1/2, because again, 1/2 minus 1 is negative 1/2. But because I have a negative 1/2, this moves to the denominator, so we can have a positive exponent. And 2 over x to the 1/2 is radical x. So this is going to be natural log of x over radical x minus 2 over radical x. And if you really wanted to, we could put these together, but we don't have to. And one quick thing, I apologize for this, but the product rule is a prime b plus b prime a, so this should have actually been a positive. Okay, my apologies. Next, we got the natural log of x to the 4th plus 4 all over 4. So here's what we know. If we take the derivative of the natural log of f of x, then this equals to 1 over f of x times f prime of x. Okay, that's what we know. So our f of x is going to be x to the fourth plus 4 over x to the fourth. Now, before I take f prime of x, it is much easier anytime you're dividing by a monomial to separate these into two different terms and divide them each by x to the fourth. So this equals to x to the fourth over x to the fourth plus 4 over x to the fourth. If I simplify this, then f of x equals to 1 plus 4x to the negative fourth. We need this to be on the numerator, so this gives us 4x to the negative fourth. Now, f prime of x, the derivative of 1 is going to be 0. Negative 4 times 4 is negative 16. X, I subtract 1 from the exponent, so that's negative 16x to the negative fifth. And if I rewrite this, then we have negative 16 over x to the fifth, since we can only use positive exponents. So that's f prime of x. Now let's differentiate f of x. So f prime of x is going to be 1 over this term. So it's going to be 1 over x to the fourth plus 4 divided by x to the fourth. So that's 1 over this term times the derivative of this, which came out to be negative 16 over x to the fifth. The derivative of this whole thing, we calculated that on the side, and that came out to be negative 16 over x to the fifth. So because of the chain rule, we have to multiply this by the derivative of the parentheses. Let's simplify this a little bit. We know that we can't divide by a fraction. So instead of dividing by a fraction, we are going to multiply by the reciprocal of the fraction. So we're going to multiply the denominator by x to the fourth over x to the fourth plus 4. Same thing on the numerator. Multiply by x to the fourth over x to the fourth plus 4. So all of this is going to cancel out. And on the numerator, here's what we have. We have x to the fourth divided by x to the fourth plus 4. And remember, we still have to multiply this by negative 16 over x to the fifth. Now here's what happens. The x to the fourth, x to the fifth, these are going to cross cancel. So this goes into itself once. And if we take away x to the fourth, we're left with just 1x. We have 5 x's, we're taking away 4. We're left with just 1x. So on the numerator, all I have is a negative 16. On the denominator, I have this x times x to the fourth plus 4. And that is my derivative. Okay, one more example. We want to find the natural log of x raised to the 6th power. So we got to use a chain rule here. Okay, the chain rule says that if we have something to a power, that power comes to the front. So we have 6 times the natural log of x to the 5th power. But then we have to multiply this by the derivative of the parentheses, which is just going to be 1 over x. So if I simplify this a little bit, I have 6 times the natural log of x to the 5th power, all of that divided by x. Okay, that's my derivative. Then I want to find what is f prime of e squared. So I replace each of the x's with e squared. So I have 6 times the natural log of x, which is e squared to the 5th power, divided by e squared. Now remember that anytime a logarithm or a natural log has an exponent, that exponent needs to come to the front and become a coefficient. So I'm going to rewrite this as 6 times 2 natural log of e to the 5th power divided by e squared. Now we know that natural log of e is equal to 1. So this equals to 1. I'm just going to cross that out. So this is 6 times 2 to the 5th over e squared. 2 to the 5th is 32. And then 32 times 6 is going to be 192. So we get 192 divided by e squared. And you have to convert this to a decimal. So you would put this into decimals or whatever your favorite calculator is. And we're going to get 192 divided by, I should have worked this out earlier and I forgot to. So this should give you 25.9844. The last example we will do in class.